Let's have a glimpse on what GCD is. GCD, or common divisor, has these properties. Given a and b integers, d will be called the greatest common divisor if it satisfies the following two conditions. That would be d divides a and d divides b. And if there will be another integer c that will divide both a and b, that c must be less than or equal to d, knowing that d is the greatest common divisor. This is our notation for GCD. Now we have examples here as well. The GCD of 6 and 4 is 2. The GCD of 12 and negative 18 would be 6. And the GCD of negative 12 and 36 is 12. And lastly, the GCD of 5 and 0 is of course 5. But for the benefit of others, let's have this. The GCD of 21 and 12 is 3. And this is the process on how we get 3. And yes, how about if we have bigger numbers such as this? Now, this is where Euclid's algorithm comes in, and it says that if we have integers a and b with the equation a equals bq plus r, then the GCD of a and b is the same thing as the GCD of b and r. But before we answer that large number using Euclid's algorithm, let's have first the smaller numbers. Knowing that 3 is the GCD of 21 and 12, let's write 21 in terms of 12. And that will be 21 equals 12 plus 9. Basing that from Euclid's algorithm, we have 21 as our A and 12 as our B with 9 as our R. Since we are after of the GCD of A and B and R, after writing A in terms of B, that's writing 21 in terms of 12. Let's now write B in terms of R, that is writing 12 in terms of 9. Algorithm would be continuing this process until R becomes 0. So let's continue writing 9 this time in terms of 3. Now, Euclid's algorithm, together with this theorem right here, assert that the last non-zero remainder in the series of equations here is actually the GCD of the given numbers a and b. Going back to our problem here, notice that 3 is the last non-zero remainder in the series of equation here, making 3 as the GCD of our a and b, or the 21 and 12 in our problem here. Before we finally answer larger numbers here, please try answering one last time this pair of numbers. As noted, a must be the greater number, so in this case, 180 would be our a, and so 180 should be written in terms of 156. Continuing the process, we will now write 156 in terms of 24. And as discussed, we are to continue making equations until we arrive at an equation containing 0 as its remainder.